So for part C, we're going to do the exact same thing we did for the other two. So find the derivative of the equation secant x minus 2 cosine x, and find a derivative at point pi over 3, 1. So the derivative of secant x is secant x tangent x, and the derivative of cosine x, 2 cosine x, is 2 sine x, negative 2 sine x, so it ends up to be positive 2 sine x. So now that you've derived it, plug in your point. So secant at pi over 3 tangent pi over 3 plus 2 sine pi over 3. Secant is just 1 over cosine, so cosine pi over 3 is 1/2, so 1 over 1/2 times tangent is sine over cosine, so sine of pi over 3 is root 3 over 2 over cosine of pi over 3 is 1/2 plus 2, and sine pi over 3 is root 3 over 2. After that, you just simplify. So this is 2 times root 3 plus root 3, because 2's cancel out. So you get 3 root 3 for your slope. And then you just plug in your x's and y's. So y minus 1 equals 3 root 3 times x minus pi over 3. And that is your tangent line. For this problem. Alright, so for the next part of this lesson, it wants you to do higher order derivatives past the first derivative. So this is the original equation. It wants us to find the first derivative. So this is 8x cubed minus 10x. Derive it one more time for the second derivative. That's 24x squared minus 10. Another time for the third derivative. That is 48x. Another time for the fourth derivative, and that's just 48. For the next problem, it wants us to find the second derivative for this equation. So dy dx, remember the product rule, it's the derivative of the first times the second plus the derivative of the second times the first. So it's derivative of x is 1 times cosine x plus the derivative of cosine x, which is negative sine x, times the first. And so your first derivative is cosine x minus x sine x. So for your second derivative, you derive it again. So the derivative of cosine x is negative sine x. Product rule for this one, the second part. So minus 1 times the second plus the derivative of the second, which is cosine x, times the first, which is negative x. And you just simplify that, so that's negative sine x minus sine x minus x cosine x. So this would be negative 2 sine x minus x cosine x. That is your second derivative for this problem. And then on to the next page is find the second derivative for y equals 4x over the square root of x plus 1. And what you have to do is the product rule. You could do I'm going to use the quotient rule. You can do the product rule too, but I'm going to use the quotient rule. So y prime equals derivative of 4 times the second minus derivative of the second times the first all over the second squared. So it's squared, so it's just going to end up as x plus 1. So if you simplify this, it's 4 square root of x plus 1 minus 2x over square root of x plus 1 all over x plus 1. You want the top to have a common denominator so you can solve it. So what you can do is just multiply x plus 1 over x plus 1 on this side. So you would get 4 times x plus 1 over the square root of x plus 1 minus 2x over the square root of x plus 1, still all over x plus 1. Now you can solve the top part. So that's 4x plus 4 minus 2x over the square root of x plus 1. And 4x minus 2x is 2x plus 4. And then after that part, you can solve the thing as a whole, and x plus 1 on the denominator is really x plus 1 over 1, and if you just multiply the fractions together, so 2x plus 4 over x plus 1 to the 1/2 power times 1 over x plus 1 to the 2 over 2, which is y just to the first power. You can combine them, so if powers are being multiplied, you add them together, so you have 2x plus 4 over x plus 1, 1/2 plus 2 over 2 is 3/2. And so that's your first derivative. And then so you do it one more time for your second derivative. Y prime. So the derivative of the first times the second minus the derivative of the second times the first. second squared. If you square that, you're left with x plus 1 cubed. After this, you just simplify the problem. So what you can do, if you notice, if you're looking to both sides, you could see they both have an x plus 1 to the 1/2 power. You can factor that out. And you're left with 2 times x plus 1 minus 3/2 times 2x plus 4. And it's all still over x plus 1 cubed. Then after that, if you factor and distribute and combine this stuff, two x plus 2 minus 3x minus 6 x plus 1 to the third could be looked at as x plus 1 to the 6 over 2, and if you put this on the bottom and combine these two, it would be x plus 1 to the 6 over 2 minus x plus 1 to the 1/2, and you're just subtracting the exponents, so you'd get 2x plus 2 minus 3x minus 6 over x plus 1 to the 5 over 2 power. And then you simplify the top. 2x minus 3x is negative x. 2 minus 6 is negative 4 over x plus 1 to the 5/2. And that's your final answer. That is the second derivative for 4x over square root of x plus 1. Then for the next part, it wants you to find the 27th derivative for cosine of x. So the first derivative of cosine of x is negative sine x. The second derivative for this one is negative cosine of x. The third derivative is sine of x, because negative sine of x. And then the fourth derivative is cosine of x, and if you look at it, it just repeated. So if you divide 27 by 4, you should be able to see which one it is, or you could just count 1, 2, 3, 4, 6, 7, 8, 9, 10. That takes so much work, so I'm just gonna divide. So in 27, 4 goes into 27 6 times. And you get 24. And so 3 more after that is this. So f of 27 of x is sine of x, because there's six times it's going to go through all the way, and then after the sixth time we go down 3. And for the last part, before we go to the EP question, it wants us to find the velocity and acceleration when t equals 4. And s of t equals t cubed minus 6t squared plus 9t. And s is in meters, so s is your position. If we were finding the velocity first, let's derive the position function. So s prime of t equals 3t squared minus 12t plus 9. And it wants us to find it at t equals 4, so we plug in 4. Four squared is 16. 16 times 3 is 48. Twelve times 4 is also 48. And plus 9, these 48s cancel, and you get a velocity of 9 meters per second. And then for the second one, we're looking for the acceleration. The acceleration is the second derivative of the position function. We already found the first derivative, so we just derive that one more time. So that's 6t minus 12, and you plug in 4 because we're looking for the time 4. 6 times 4 minus 12 has to be 24 minus 12, and that's just 12 meters per second squared, because it's acceleration.